Thank you very much. I'm very happy to be here, and today I'm going to talk to you about dyslexias and different types of dyslexias and the way they manifest themselves in different languages, including sign language. And I think there are several questions that we ask ourselves when we talk about dyslexia and its interaction with different types of languages. And the first is, and I think sometimes people say that, maybe there are languages in which there is no dyslexia. So I'm going to ask this question. I will not tell you what I'll answer, but you'll see soon. Another question is whether it's possible that there will be an individual who is bilingual, multilingual, who will show dyslexia in one of his languages, but not in the others. Another question that I'm going to ask is whether there are dyslexias that are simply easier to detect. They exist in all languages, but maybe easier to detect in one language than in another language, and why it is like that. And if it's like that, then what do we need in order to identify different dyslexias in languages of very, very different properties? And I will go a bit more deeply into the different properties of orthographies of languages and the way they dictate how dyslexia will manifest itself in this language. So I'm going to talk about the effect of how predictable reading in this language is, diglossia, so the phenomenon in which there are two languages, one spoken and one written within one community. I'm going to talk about morphology, about different reading directions, about letter forms, and about whether or not all vowels are consistently represented in a language. So I'm going to start with just generally talking about what do we do when we look at when we read a word. So we start with the written word, and then we get to comprehension, to understand this word, and to saying the word out loud. So it's a multi-stage process that starts with some kind of visual analysis of the sequence of letters, works through lexicons, and goes to comprehension, and also allows for reading new words by conversion of letters to sounds. The important thing for us is that a deficit in each of these stages, in each of these components, can give rise to a dyslexia, to a different kind of dyslexia. And we currently know of 23 different types of dyslexia. So we have heterogeneity with respect to the different types of dyslexia, but we have another very important heterogeneity that we need to take into account, which is the heterogeneity of the different languages. So what I'm going to do today is take this heterogeneity of the different languages, take the heterogeneity of the different dyslexias, and look at the way they interact. And the data that I'm going to show you come from research in several languages with large groups of individuals, both acquired and developmental dyslexia, in Hebrew, Palestinian Arabic or Standard Arabic, Turkish, Italian, French, and Israeli Sign Language. These are the main languages. Sadly, I don't have data from Chinese and Japanese, which would be very relevant. But within these languages, I think we can learn a lot about the interaction between language, orthography, and dyslexia. And I start with letter position dyslexia. Letter position dyslexia is a dyslexia, you can guess by its name, that affects the position of letters within words. So these are examples in English of errors that a patient with letter position dyslexia did when he had to read the words on the left, and he read them as the words on the right. So you can see very clearly that there is a very clear pattern of errors, right? The errors are letter transpositions within the word and mainly in the middle of the word. Okay? So we know quite a lot now about this kind of dyslexia. First of all, when we look at the model, I told you that there is a very first stage of visual analysis, of orthographic visual analysis, in which we perceive the sequence of letters, identify the abstract identity of the letters, identify the position of the letters within the sounds, within the words, and then bind letters to the words in which they appear. there is a problem, the letter position dyslexia is a problem in this stage, and specifically in the stage of encoding the relative position of letters. So what it causes is, first of all, a problem in reading aloud. It causes transpositions in reading aloud, like slime that becomes smile. And we can see that control participants without dyslexia make few errors, less than 2% errors. And this is data from 220 participants, Hebrew speakers with letter position dyslexia. They make errors on almost a quarter of the words that they read. We actually work with more than 220 participants. It's quite a common type of dyslexia. And so it affects reading aloud, but it affects not only reading aloud. Because this very first stage is also before the stage of comprehension, then it affects also comprehension of written words. So they would understand the words. If they made an error of letter position, they would also understand the words incorrectly. So this you could see in various tasks. But for example, when you ask a participant to define a word, this is an Australian child. I showed him the word could and asked him to define the word, and he said it's something that brings rain. Why? Cloud. And why are parties very brave? They are robbers of the sea. Pirates, right. And here's an example in French that Cassandra Potier-Watkins collected. And why patron is let's go. Okay? So once you ask them to define the word, you see that it's not only in the production of the word, it's not only in reading aloud, it also affects comprehension. And of course, that's crucial when we want to read a paragraph, not only in school, in every day, we want to make sure that we understand the correct word and not its migration counterpart. So we also see a lot of migrations in comprehension. So as you've seen before, one of the properties, when we look at the properties of this dyslexia, is that when we compare migrations in the middle of the word and migrations that affect the first and the final letter, we see that there are far, far more migrations in the middle than in the exterior letters. It will become relevant afterwards when we try to invent words for other languages. But the most important property of letter position dyslexia and the way it interacts with different languages is migratability. What do I mean by migratability? Let's look at these two words, from and frog, okay? From is a migratable word. Why is it a migratable word? Because if I transpose the letters in the middle, I get another existing word, right? From becomes form, and vice versa. However, if I take the word frog, it's a non-migratable word. Why is it non-migratable? Because if I transpose the middle letters, I don't get another existing word in English, okay? And when we compare migratable words and non-migratable words, and we look at how many errors the participants with LPD make on migratable and on non-migratable words, what we see is a very, very, very clear difference between migratable words and non-migratable words. They make transpositions on from, but not on frog. Okay? What does it mean for the diagnosis of LPD in various languages? It means that we have to include, if we want to diagnose letter position dyslexia, we have to use these kind of migratable words, right? Because otherwise we will miss this kind of dyslexia. If we present only non-migratable words, if the whole list is frog words, then we don't see this dyslexia. Okay. So, for example, if you would like to identify letter position dyslexia in French, what should you do? So this is what we did, Professor Stanislas Dehaene and I. We set, this is the games that we play. This is what we like to do. We set and invented a list of migratable words in French. So can you imagine what can result from these words in transposition of middle letters? Okay, so these are very good words to identify letter position dyslexia in French. And indeed, we worked with the wonderful Cassandra, and what we found are individuals who have letter position dyslexia in French. And you can see some examples of a sixth grader who makes errors in letter position. This person would never be identified without this list of migratable words. So using these migratable words, we were able to identify letter position dyslexia in Hebrew and in Arabic, in English, in Italian, in Turkish, in Russian, and in French. So let's think what would happen to a child or an adult who feels that something is wrong with their reading, but they don't get a list of migratable words. So we don't have to imagine too hard. I'll give you an example of children in Australia, in Sydney, who came to the clinic led by Saskia Konen. They came to the clinic with complaints. Either they said that they find it hard to read, or their parents or their teachers said something is wrong with their reading, but we don't know what. And they were sent to the clinic. And Saskia Konen gave them the standard tests, the CC2 and the WIA test and the non-word reading, and their performance was normal. What does it mean? It means that the number of errors that they made on these tests was within the normal range, like individuals without dyslexia. So they don't have dyslexia. The first thing that I think, the most important thing is when a child or an adult comes to you and says, I feel I have a problem in reading, you say, okay, let's help you find why. Okay, you don't say, no, you're normal. You don't have a problem. Okay? You could say, I couldn't find it, but you cannot say you don't have a problem. If you feel you have a problem, then let's find out. Luckily for them, Saskia Konen had in the drawer a list of migratable words in English. This is a present that I gave to Ann Castles from the same university for her birthday. This is the kind of birthday presents that we give. So Saskia took from the drawer, she took the list of migratable words. She said, maybe this is the problem because I don't see what the problem is. And she gave it to the first child. And finally, she understood what was bothering him. He made a lot of transpositions. And it was the same with two other children who were complaining that their reading is not good, but their standard tests seem to indicate that everything is fine. Okay? So here we can clearly see the difference between a test that includes sensitive stimuli for this dyslexia and a test that doesn't. So the moment we use the right stimuli to identify dyslexia, we are able to identify it, and in this case, for letter position dyslexia, it's migratable words. So we may miss letter position dyslexia if we don't use migratable words, and if we diagnose, we should include sensitive words that are sensitive to each type of dyslexia, in this case, migratable words. Now there is something else that is important, which is if we look at a random list of words, let's assume that a test or a text that a child has to read or an adult has to read in a dyslexia diagnosis is a random list that is not selected according to migratability. Then there are languages in which there are many migratable words, like Hebrew, for example. And there are other languages, maybe like English, in which there are not many migratable words that appear randomly. Then it will explain why it's more difficult to detect by chance, by random, letter position dyslexia in English than, for example, in Hebrew. Why is Hebrew so sensitive to letter position dyslexia? Why was letter position dyslexia identified in Hebrew for the first time? You know, when we discovered this dyslexia, and I told people, we discovered this kind of dyslexia, letter position dyslexia, and people ask, what are they doing? And I said, well, they transpose letters in the word. I said, okay, that's dyslexia. So in Hebrew, for Hebrew speakers, it's clear that there are these kind of errors. Why? Because there are many migratable words in Hebrew. And here we see again the interaction between a dyslexia and the properties of a language. So, for example, if you take the letters of English, you get English, but in Hebrew, All these transpositions are existing words in Hebrew and more. Why is it the case that there are so many migratable words in Hebrew? First of all, because in the orthography, not all vowels are represented in writing, and therefore, if you make a transposition, you can also change a lot of the vowels when you pronounce the word, and then you have a better chance to get another word. And also because of the morphology of Hebrew. In Hebrew, words are built from 3 letters of the root and from morphological affixes. And there are many, many roots that differ only in the order of the letters of the root. And there are also affixes or templates that differ only in the position of one of the affix letters. So it creates a situation in which there are many migratable words, and therefore, even if you get a random list of words, you might detect letter position dyslexia. In other languages, you have to make a bit more effort and create a list of migratable words. Now, the question is, why should we make an effort? So, is it the case that, so if, for example, in English there are not many migratable words, maybe it's not so important to identify letter position dyslexia. So, first of all, remember that these children in Australia, they came to the clinic because they had problems in reading. Okay? They didn't know what the problem was, but they felt that reading is difficult for them. I want to show you another person who has 2 languages, who speaks 2 languages, and also complained about reading. Okay? So the question now is, what happens when there are 2 languages within the same person? It's a lot of words, but I'll tell you about DA. DA was a patient in the rehabilitation center. He was born in India. He was speaking English until he was 30-something, and then he moved to Israel, and he was speaking Hebrew for 18 years. But he really, really liked to read, but he read mainly in English. It was better for him to read in English. This was his first language, and he felt comfortable in English. He had a stroke 8 months before we met him, and he complained that he can't read anymore. It's not comfortable for him to read in English. And nobody knew why, and we didn't have a test in English that would be able to identify his problem. And we ran the standard tests. And the standard tests, again, showed that he was normal. So there is a person who really likes to read and stopped reading because it was very, very difficult for him to read. And the tests say that he's normal. So what is going on? We used the fact that he was reading Hebrew as well as English. We had tests for letter position dyslexia as well as other dyslexias in Hebrew. So we tested his reading in Hebrew using migratable words. We tested his reading aloud, his definitions. You saw before why it's important. We did same different decision with 2 words that differ in the position of the letters. We asked him to decide whether T-A-L-B-E, for example, the counterpart in Hebrew, is a word or not. And we asked him to read text aloud with a lot of migratable words. And again, what we saw is that he made a lot of migration errors. And then we said, okay, so if we see this kind of dyslexia in his reading in Hebrew, maybe this is what bothers him in English. So what we did all night, we set, this was the first list that we had of migratable words in English. We set and created lists, tried to think of words in English that are migratable. The night ended with very little sleep, but 36 pairs of migratable words in English. And the day after, we gave him the same tasks, but in English. And what we found is actually he's the one who made the errors that I showed you before. So he made a lot of transposition errors, and only transposition errors in reading and definitions and in lexical decision. What does it mean? It means that if we, first of all, he had letter position dyslexia in both languages, right? We just needed the right stimuli in order to identify them in English, his first language. But the second thing is, I think, goes into asking whether it's worth, putting the effort into identifying dyslexia in a language in which you don't see it in a random list of words. And actually, I think it does. It's actually very important to identify the type of dyslexia, even if it's not easy to identify it. Why? Because this person stopped, he really liked to read, and he stopped reading because something bothered him in English. And we didn't know what. And now we do, and then we can apply the various types of treatment and manipulation on text that we can in order to help him read, and this is actually what we did. And he came back to reading. He was reading with a pen that pointed to the second and third letters of the word, and it helped him read. So yes, sometimes in some languages it's harder to identify a dyslexia, but it's worth our effort of identifying it also in these languages. Let's take another example of a bilingual person with letter position dyslexia, but here I want to make a different point. So now we're talking about a Hebrew-Arabic patient, Hebrew-Arabic speaker, a person who was very fluent in both languages. He was born to an Arab-speaking family, but a lot of his social life was in Hebrew. He was 28 and he had a traumatic brain injury. He was in a fight, and he had letter position dyslexia and also letter position dysgraphia in both languages. And we tested him with a list of migratable words. We have them in Hebrew, we have them in Arabic, and this is what we find. So he made 23% migrations in Hebrew, but only 9% migrations in Arabic. What is going on? So Arabic and Hebrew are very similar, both in the morphological structure. Both of them have Semitic morphology. They're very similar in that Arabic also doesn't represent the short vowels in writing. So essentially they have a lot of migratable words. Why does he make so few errors in Arabic in the same kind of task? So we were very puzzled in the beginning. And then we went to look at letter forms in Arabic. So I'll tell you a bit about letter forms in Arabic, and then we'll join the two types of data and understand what was going on. So in Arabic, there are different letter forms for many of the letters. There are different letter forms for the same letter when it appears in the beginning, and I'm doing it from right to left because Arabic is from right to left, in the beginning, in the middle, and in the end of the word. So the same letter can appear in different forms, in different positions. So for example, this is Ain, the glottal A, this is H, and this is what you can see in the top. This is in the beginning of the word, this is in the middle of the word, and this is in the end of the word, connected and not connected to the previous letter. And this is H, beginning, middle, end connected and not connected. Okay? So you can start. Once the letter form is connected to the letter position, then you can start understanding why he made fewer errors. Okay. So if we look at migrations, for example, let's look at the letter Ain, when it appears in the middle. Okay, this is the same. Here it's the second letter, here it's the third letter, and it preserves its form, right? But what happens here? You can see the letter Ain when it appears in the third position and in the second position, and it looks differently. So what would happen if there is a transposition in the second pair? It will change the letter form. So we tested 10 participants with letter position dyslexia. We gave them migratable words that change the letter form, migratable words that don't change the letter form, and other two conditions. And what we see is that they are very careful not to change the letter form. So they do not make migrations if they change the letter form. They only make migrations if they keep the same letter form in the two words. So they do not make errors, migration errors of the second type. They do make migration errors of the first type. What does it mean? It means that letter forms keeps the Arabic reader from making transposition errors. So what do we need to do in order to identify the letter position dyslexia in Arabic? We have to present migratable words only that do not change, in which the transposition do not change letter form. And when we compare only same form migrations, we see very similar percentages of migrations in Arabic and in Hebrew. Okay? So again, it's the same dyslexia. It affects the person in the same way in his two languages. It's just the properties of the language that modulate and manipulate the percentage of errors that he makes. Okay. When we look at Turkish, we see the same pattern. This is work with the Selçuk Gülven, and what we see is again migrations, mainly of middle letters. There is something interesting that I wanted to tell you about here, and this is that in Turkish we were able to answer a theoretically important question, which is usually in Hebrew we only compared, and in Arabic we compared migrations in which two consonants migrated, transposed, and cases in which a consonant and a vowel transposed. But we didn't have enough migratable pairs in which two vowels change place. So what we did here in Turkish was comparing consonant-consonant transposition, consonant-vowel transposition, and vowel-vowel transpositions. And what we found is a huge difference between consonant-consonant transpositions and transpositions that involve vowels. What does it mean? Remember that letter transposition happens in the very, very first stage of visual analysis. It means that already in this very early stage, we are sensitive to the consonant-vowel status of the letter. Already in this very first stage, pre-lexical stage. Okay? So our system is, when it identifies a letter, it already knows if it's a vowel or a consonant. Why is it important? We know from dyslexia that I'm not going to discuss today, which is called vowel dyslexia, that actually when we convert letters to sounds, we convert vowels separately from consonants. How do we know that? Because there is a dyslexia that affects only vowels, and there is a dyslexia that affects only consonants. So the very first stage is already making the distinctions between consonants and vowels, and then it sends vowels to the vowel root and consonants to the consonant root. So this is not especially about the interaction between the properties of language and dyslexia, but it shows you how we can use properties of a language in order to learn something important about cognitive theory. So I told you that we identified vowel letter position dyslexia in all these languages. But now I want to tell you about a non-printed modality. I want to tell you how letter position dyslexia looks like in sign language, and specifically in finger spelling in Israeli Sign Language. And we did this study with bilinguals who read Hebrew, written Hebrew, but they also read finger spelling. So I'll say something about finger spelling. So in general, and this is work with my two PhD students, Neta Chalutz and Doron Levy, who's a deaf person who uses sign language to communicate. So sign languages are natural languages in all respects. They have syntax, semantics, phonology, morphology of their own. But importantly, usually when we talk about signs, they are parallel to whole words. So house, or name, or Italy. Okay? But what happens when we want to use a name that doesn't have a sign yet? Okay? Exactly. So if we want to say Luigi, for example, I don't know that Luigi Professor Rizzi already has a sign in Israeli Sign Language. So if I want to communicate about him, I will have either to point to him, which is not very polite, or to use his name in finger spelling. So I would say Luigi in finger spelling. Now, of course, finger spelling and reading finger spelling is a type of reading, okay? So if I say I'll do finger spelling in Israeli Sign Language, okay? So it's Lamed, Vav, Yud, Gimel, Yud, Luigi. Then there should be, what is the process of reading finger spelling? What do we use when we read finger spelling? So my main question was whether we are using exactly the same process that I showed you before, reading process, as we do with written languages. And I asked it through the analysis of two cases, two bilingual users of Israeli Sign Language who read Hebrew. And in both languages, or let's start with, I will not tell you, in Hebrew they have letter position dyslexia. So we tested them in Hebrew and we tested them in finger spelling. And so how do you test reading in a signer who doesn't produce voice in his speech? How do you test reading aloud? So you can't test exactly reading aloud, but what you could do is show finger-spelled words and ask them to finger-spell them, or show finger-spelled words and ask them to translate them into sign language, so to sign the word. So if the word is, I don't know, a house, then they have to sign a house. Okay? And we did this, exactly the same. We used the same tasks for written words and for finger-spelled words. So we used, for example, reading aloud in written words and in finger-spelled words. We used pointing to reading and pointing to a matching picture in written words and in finger-spelled words. And what we found, first of all, is that they make a lot of transpositions in reading written words in Hebrew. So, for example, if we showed Yona, it was a young woman and a young man, Yona and Alon. We showed Yona the word tris, shutter, and she read it, and she signed tris, which is a corn, tiras, which is corn, okay? So she made transposition. It's not easy to see it, but it's a transposition of middle letters. And then we finger-spelled words to her, actually the same words. So, for example, we finger-spell the word cables, which is migratable with the word dogs. So she read the word cables, but she signed dogs. So what happened was that she saw the letters, the finger-spelled letters. She identified the finger-spelled letter correctly, but she just made the migration of the middle of the letters in the middle. So she had letter transposition in the middle, both for written words and for finger-spelled words. And exactly the same in word-to-picture matching. So this is scientists, but it's transposable to dairy products. So we signed scientists, and she pointed to dairy products. And this happened both in written words and in finger-spelled words. And the properties of the errors were very similar. They happened in middle letters. There were more errors in migratable than in non-migratable words. And I will not talk about double letters. So we concluded that we actually, to read, we are using the same first stage of orthographic visual analysis for written words and for finger-spelled words. And it surprised us, because finger-spelled words, as you can see, if we do lu, he, g, you see that each letter appears separately. So what it means, so why is there a deficit in the position of letters in the middle? We think that there should be a buffer that holds the finger-spelled letters. It holds them, and then the position encoding acts on this buffer. And the deficit is in identifying the position of the letters within this buffer. So this was letter position dyslexia and its interaction with letter forms and with morphology and with finger spelling. And now I'm moving shortly to neglect dyslexia. I'm going to tell you about 4 more dyslexias. This one is going to be short. And now the interaction is with the direction of reading. So what is neglect dyslexia? Neglect dyslexia, let's start with what is generally visual spatial neglect. Visual spatial neglect in general is a deficit in shifting attention to one of the sides of the space, usually to the left side. So this is a patient that we asked to circle all the lines that he sees. Okay, and he circled all the lines that he paid attention to, let's say. And he omitted all the lines on the left. This is another patient that I asked him to draw a clock. So first of all, you see that he drew the whole circle, which is interesting. And then he put the numbers only on the right side. He ignored the left side and neglected the left side. But he remembered there were 24 hours in a day. So he tried to fit all the 24 hours on the right side. So this is spatial neglect in general. But then you can think what happens when someone with this kind of impairment reads a text. When they read a text, the problem is in the left, usually in the left side of the text. And what they do is usually omit. They usually omit words on the left side of the text. So just to clarify, in Hebrew is read and written from right to left. So omission on the left would be the end of the sentences. And English is written from left to right, so the omission will be in the beginning, in the left, both of them in the left side, but in one case it's shifting attention to the left, and in the other case it's shifting attention to the right. And we had a patient, again a bilingual patient, who was 77 years old after a stroke, and she read Romanian and English and Hebrew. So we tested, and she had neglect, and we asked her, we tested her reading in these languages. And we tested her general spatial neglect, and she had a very clear left-sided spatial neglect. Just to show you, for example, these are, on the left you can see drawings that she had to copy, and on the right you can see how she copied them. And you see that she omits the left side? And here she had to mark all the letters, these letters, Hey and Tzadik, both in Hebrew and in English. And it's a bit difficult to see, but she neglects the left side. So what happens in reading? When we asked her to read text in Hebrew, what she did was very consistently, she didn't read the letters, the words all the way to the end, to the left side. So I marked here. So she read the lines, but not all the way to the end. Okay? And she stopped. And this happened, I think she read 13 texts. She had problems in all of them. What happened in English? I'm happy to tell you. She read well. She didn't omit anything in any of the texts that she read. So she read 13 texts in Hebrew. In all of them, she omitted words on the left. She read 10 texts in English. She didn't omit any word on the left. So what is going on? I would like to suggest that if we take into account the direction of the two languages, we can understand what is going on. Because neglect is a problem in shifting attention to the left. But in Hebrew, you all the time, from each word to the next, you have to shift attention to the left. In English, once you put your attention on the left, then you only have to shift right. So there is a difference that results from the difference in the reading directions. Now I have to say that this is the only case that I saw many neglect patients. And in most cases, their neglect affected all their languages. But this is a case that was very, very different. Once she was able to put her attention on the left, then shifting attention to the right was not a problem anymore. So we see some kind of interaction between reading direction and the manifestation of dyslexia. Okay, so this was neglect, and now I'm moving to surface dyslexia. That's our third dyslexia for today. So we had letter position dyslexia, we had neglect dyslexia, and now we're moving to surface dyslexia. Surface dyslexia is a very famous type of dyslexia. So I'll just remind you that when we look at the model of reading, at the process of reading, we actually talk about one route that is a lexical route, in which we read words that we already know. So this model, this route goes through a list of words, written words that we know, the orthographic input lexicon, to the list of words that we know how to pronounce, the phonological lexicon, and this is the lexical route. And there is another route that is the sublexical route, that allows us to read words that are not in our lexicon yet, and we read them by converting letters to sounds. So what happens when someone has a problem in the lexical root? They can read each word as if it were a new word, to convert letters to sounds. And this is surface dyslexia. It's called surface dyslexia. John Marshall baptized it as surface dyslexia because you read on the surface. You don't go through the lexicon. You read on the surface, you just convert letters to sounds. Why is it a problem if we read each word as if it were a new word just by converting letters to sound? First of all, especially with long words, it's slow. It takes time to convert letters to sound instead of seeing the whole word, identifying it, and saying it. But there is a worse problem, which is that it's inaccurate. Because if you think, and I mentioned it in previous talks, if you think of a word like walk, you might read it as walk, and talk, talk, and sword, sword, and stomach, stomach, and door, dur, etc. So if we read these kind of words that are unpredictable or irregular, we might read them inaccurately if we read them as a new word. And this is the problem in surface dyslexia, is inaccurate reading aloud of irregular or unpredictable words. There's also a problem in comprehension. I will not get into it. So in English, where surface dyslexia was first identified and described, it's very clear reading irregular words. So words with silent letters like walk, and words with unpredictable conversion like door. Irregular words are read less accurately than regular words. And then you can think about different languages in terms of whether it is a language that is transparent. So reading words as new words usually gets you the right word, and languages that are not transparent. So if you read the word via the sublexical route, you don't get to the right reading. So one extreme is Hebrew, for example, because in Hebrew there are no regular words. So if you look at a Hebrew word, there is for each word there are several hundreds of ways to read, because because the vowels are not always specified, because a lot of consonants can be read in different ways. There is a lot of ambiguity. So reading via the sublexical route usually will not give you the right answer. And there are other languages in which it's easier. What do you say about French? Is French transparent? Not great. Okay? French is a great language, really great language. But sometimes there are some letters that appear in the word and you don't need to read them. And so if someone reads a word in conversion of letters to sounds, there will be all these letters that they will pronounce. As when I was a child, we had a Renaulx. So I didn't know that it should be Renault. There were all these letters and I read them. Okay, so French has a lot of irregularity, and therefore surface dyslexia manifests in it in a very pronounced way. So what do we need to identify in order what kind of words do we need to present in order to identify surface dyslexia? For example, in French, we need the irregular words. And again, Professor Dehaene and I came up with a list of irregular words that sound differently from how they are written. Okay, so if you read them by conversion of letters to sound, you don't necessarily get to the way the word should be pronounced. One more important thing to know about surface dyslexia is that there is a specific kind of word or kind of words that are especially difficult. And these are the ones that if you read the word via the sublexical route, you get to a word, but it's not the word that is written. And we call it, in the very easy word, potentiophones. So you have a potential for reading this as a different word. So let's take the example of the word now, N-O-W in English. Okay? If we read the word now through the lexical root, we read it as now, right? But what happens if we read it through letter to word conversion? Exactly. We might read it N, O, U. No. Okay? So it might sound as no. So this is a potentiophone, right? If we read it sublexically, we get to another existing word. So this is already a challenge, right? But Professor Dehaene was able to identify words like that in French. So have a look here. You see that these words can be, if you read the word on the left, sublexically it might sound like the word on the right. And these are the best items to identify surface dyslexia, because if someone reads a word incorrectly but it doesn't create a word, they will correct themselves and try again. But in these cases, they don't know that it's not the target word. Okay? So these potentiophones are the best words to present. So what do we want for diagnosis? We want to present irregular words, and preferably we want to present potentiophones in order to identify surface dyslexia. But so we talked about Hebrew, we talked about French, English is also an irregular language. But then there are these languages that are quite transparent. So when you read each word as a new word, usually you get to the right word. And this is the case in Italian, in German, in Greek, in Turkish. These languages allow for a considerable amount or percentage of the words to be read correctly sublexically. So does it mean that surface dyslexia doesn't exist in these languages? So what I want to say, and I'll show you, what I want to say is exactly as I said in the letter position dyslexia case. The same dyslexia exists in all the languages. You just have to know how to identify it. Okay? So even though you don't see it usually in the random list of words, if you know how to identify it, you'll find it also in Italian, and you'll find it also in Turkish, and you'll find it also in German. So here in Italian, Zoccolotti, Pierluigi Zoccolotti worked a lot on this, Claudio Luzzatti and others, and they had a very good idea. The idea was to take words, in Italian stress position is usually not marked, so you can take words of 3 syllables, and then, reading via the sublexical route, you wouldn't know if you should put the stress on which syllable to put the stress. And you can see the first 2 lines is matita, carota, gelato. Gelato, I'm sure you know. But the second lines, the third and fourth line is fegato, debito, bambola. So you sense the difference in the position of the stress? So if you present 3-syllable words, then you can identify this kind of dyslexia, and indeed people did. So you just have to look at the language, analyze what kinds of words are do not allow themselves to be read as a new word correctly, and then present these words. And using these words, indeed, surface dyslexia was identified, for example, in Italian. So instead of reading conserva, reading conserva, instead of reading partono, partono, etc. Okay? And the same in Turkish. In Turkish, Selçuk Güven was able to identify types of loan words that are written with a short vowel but actually should be sounded out as long vowel, and he was able to identify surface dyslexia. So the idea is that, okay, the idea is don't give up. The dyslexia exists, you just have to try harder to find the types of words that will identify this kind of dyslexia, and we know why it's important. Because the person feels a problem in reading, it's just that we are unable to identify this. So there are people who say that there are no dyslexia there is no dyslexia in Turkish or in Italian, or it is not possible to identify these dyslexias using reading errors. It's not true. You just need to find the right stimuli and present the right stimuli. Okay. Another approach is not by using specific words, but by using other tests. And I'll say shortly something about Sasha, who is a bilingual Russian-English, or multilingual Russian-English-Hebrew speaker. And he was a poet. He really, really liked to read poetry, but also all kinds of philosophy and a lot of words. But he had dyslexia. And his dyslexia was very, very clear in Hebrew, and it was very clear in English. So in Hebrew, he had 24% surface errors. It's a lot. It's really a lot. It's a quarter of his words were read incorrectly, and mainly on potentiophones. But when we tested it in Russian, in reading aloud, he was 100% correct. But he says, I feel that I have the same problem in Russian. But we can't see it. He has 100%. Nobody does 100% correct, but he did. So does it mean that he doesn't have surface dyslexia in Russian? No, it just means that we were not able to identify it yet. And what we did with him is we showed him, we gave him words for lexical decision. So you are not able to, now we already have ways to identify surface dyslexia also in reading aloud. But what we showed him is words like robota, that we wrote once with an O and once with an A. And he had to circle the words that was written correctly. And once we did this, we were able to identify his surface dyslexia. Okay. So the idea is that we have to try to find the right task to identify the dyslexia and the right stimuli. I said that already, but maybe I'll stress this before I go to the next dyslexia. So there are researchers who say that because there are languages that are transparent, like Italian, then in these languages it is impossible to identify dyslexia by reading errors. So there are two things that we should remember. The first is that transparency only relates to surface dyslexia. It doesn't relate to letter position dyslexia or to neglect dyslexia or to the 20 other types of dyslexia. It only refers to surface dyslexia. So even if a language is transparent, you can still identify transpositions and letter substitutions and letter migrations between words and omissions of letters on the left. So that's the first thing. The second thing is that even surface dyslexia, if you find the right stimuli, you will be able to identify it in these languages. So this is surface dyslexia. And we are progressing now to phonological output buffer dyslexia, our penultimate dyslexia for today. So we talked about letter position dyslexia, about neglect dyslexia, about surface dyslexia. And now we are going to talk about an impairment that is in the last stage of the production of reading aloud. So when we look at the model, we see this is the phonological output buffer. So the lexical root and the sublexical root end in the same component, which is the phonological output buffer. It's a short-term memory component that holds phonemes until we finish producing the word. But it doesn't only hold phonemes, it also assembles. So when it gets phonemes, it puts them in the right order and assembles the words. I'll show you in a second that it not only assembles phonemes, but it also assembles other things. So when we look at the model, it is the final stage in reading aloud, but it is also the final stage in speaking. So when you start with an idea and you get to the semantic, to selecting the word, and then you get to the phonological form of the word and say the word, the phonological buffer is there too. So it has a lot of responsibilities, not only in reading aloud, but also in speaking. And even when we are asked to repeat a word or a non-word, if we hear the word zivlaza and we need to repeat it, we are using the phonological output buffer. So it's an important component of all kinds of language production tasks. And when someone has a problem, and therefore, when someone has a problem in the phonological output buffer, they have problems in reading aloud, in repetition, and in the production of words, mainly of long words and morphologically complex words. Why? Because as I told you, it's a short-term memory component. And if it's a short-term memory component, it is affected by capacity. So it can hold a few phonemes, but not many phonemes. So here's an example of Dana, a girl who came to us because she had difficulties. She was a Hebrew speaker, but in school we learned Arabic. A lot of us learned Arabic. And she had a lot of difficulties. She found it really, really difficult to learn Arabic, and she wanted to know why. And when we asked her to read non-words, so pseudo-words, this is what she did. Gnartim, she said gratim. Tchitzet, she said tachitz. Damulitza, she said damuspitza. Zchisa, she succeeded. Shadukalo, she said shul, du, klau, shudukulu. And you could see her face, she was suffering. It was really difficult for her. She could read existing words, short existing words without much problem, but this was really difficult for her. And it's not a problem in converting letters to sounds. Why? Because even when we asked her to repeat non-words, she showed the same pattern. So she couldn't, the word was shirt leg. First of all, her shoulders went lower. She really showed that she felt that it's very, very difficult for her. And she said, shir leg, shirt leg. So it was very hard, both repetition of non-words and reading of non-words. And her deficit was in the phonological output buffer. Now, individuals who have deficits in the phonological output buffer could be like Dana, could have a deficit from birth, and actually all her family has the same problem. And it could be an effect of stroke, of brain damage. So I'm going to show you Zed, who is a patient who had a phonological output buffer due to brain damage. And this is how I asked him to name. Remember that in naming and speaking, the phonological output buffer also participates. So this is what he said. For elephant, I don't know, it doesn't, probably my problem, it doesn't sound, I don't hear the sound, but I'll be Zed. So he said, Efeleifen for elephant, or ma umbrella for umbrella, or for heart, he, ha, har, no, ha, he couldn't say it. And for dress, he said dressel, dressel. Okay, so he had some knowledge of the phonemes that need to be there, but it was very difficult for him to actually produce the word. Now, on the same meeting, on the same day, we asked him to read numbers, multi-digit numbers. The same person, and this is what happened. So instead of 6,790, he said 3,390. Instead of 48, he said 408. Instead of 129, he said 209. Okay? So what is going on here? This person is making a lot of phonological errors in real words, but when he reads multi-digit numbers, all of a sudden, he doesn't make phonological errors. You see that? He doesn't make phonological errors of the type that he made in real words. Instead, he substitutes one number word with another number words. So it tells us something about the way the phonological output buffer is built. What does it tell us? We think, and we together with Dror Dutan, but it builds on work of Dehaene and Cohen, is that actually the phonological output buffer holds not only phonemes, but it actually holds units of different sizes. It holds phonemes, but it also holds number words. And then, if there is a deficit in the phonological output buffer, if the deficit is in a phoneme, then one phoneme is replaced by another, or a phoneme would be omitted. But in number words, one number word would be substituted with another number word. Okay? So it means that the phonological output buffer actually holds not only phonemes, but also units, pre-assembled units of number words. And when we look at other kinds of complex words, like morphologically complex words, what we see is that these patients make errors like thinking that become think, girls to girl, disagreements to agreeing, sings to singing. You see what is going on here? We see morphological errors, so errors in the inflections and in the derivations of the words. The morphological affix is omitted or substituted. So what does it mean for the phonological output buffer? It holds phonemes, it holds number words, but what we suggest is that it also holds whole pre-assembled affixes, inflectional affixes, derivational affixes. And then when there is a deficit in the mini store of the morphological affixes, one affix can be substituted with another, or an affix can be omitted or added. And another type of words that are difficult in this dyslexia are function words. So patients with this kind of deficit would omit function words. So instead of reading the boy tasted from a cake that was on the table, they would read boy tasted the cake on the table. Okay? So what we see is omission of all kinds of function words. What we suggest, Dehaene and Friedmann suggest, is that the phonological output buffer holds phonemes, it holds morphemes, it holds function words, and it holds number words. Okay? So it gives you a very rich view of the buffer, and it tells us again a way in which dyslexia would interact with the properties of the language. Languages that have very rich morphology would pose a problem to individuals with phonological output buffer impairment, because we will see a lot of morphological errors in these cases. Languages that are not as rich morphologically will show problems in function words and in phonemes, but not in morphology. So that's another kind of interaction between languages. The last thing that I want to say about this dyslexia before I finish quickly with the last one is what happens when we talk about phonological output buffer. What happens when a person has phonological output buffer deficit, but this person is a signer who uses sign language? How would a phonological output buffer, we claim that sign language is a natural language, that it is represented very similarly to spoken languages in the brain. So if there is a deficit in the phonological output buffer, how would it look like in people with phonological output buffer who are signers? And here I can tell you about Sunny. Sunny is a multilingual. She speaks Hebrew and Romanian and English and the Israeli Sign Language. And in her everyday, she uses with her partners, she uses only sign language. So she's very fluent in spoken languages and in sign language. And she had a stroke in the left hemisphere in the temporoparietal area. And after the stroke, she had a deficit in the phonological output buffer. And we could test how her deficit looks like in spoken languages and how her deficit looks like in sign language. So in Hebrew and Romanian and English, we saw the very, very classical deficit, a lot of phonological errors. We saw problems in speech and in reading, and in reading aloud and in repetition, and in naming, all these phonological approximations that I showed you before. What happens in sign language? So one word should be said about what is phonology in sign language. So when we talk about phonology in sign language, there are actually parameters, phonological parameters in the sign. So signs differ in the shape of the hand. They differ in the place of articulation. So it could be next to the forehead, it could be next to the to the cheeks or to the shoulders, and there is a difference in movement. So each sign has its own movement. So what did Sunny do when she had to produce her sentences or words, signs in sign language? What we saw are deficits in all these parameters. So she made errors in shapes. She wanted to say this is English in Israeli Sign Language, and instead she said English, you see? Instead of using the two fingers, she was using all the fingers. She said English. She wanted to say hot. Hot. She said hot. She placed it in the incorrect position. The movement was correct, but it was in the wrong position. She wanted to say teacher, and she said teacher. So instead of using two hands, she was using one hand, and instead of using this position, this place of articulation, she used this place of articulation. So we could see that she made phonological errors in her production. I think I had a picture of Doron, my PhD student, showing her errors. Yes, here. Shop. Shop. You see the difference? Dog. Dog. See the difference in the hand shape? Teacher. This I showed you. Teacher. Refrigerator. Refrigerator. A different orientation of the hands. So we see phonological errors in phonological output buffer impairment. Oops, sorry. But importantly, what we also saw her doing is morphological errors in sign language. So she would make, for example, errors in a plural, adding a plural morpheme, or there is a morphological difference between verbs and nouns. She would do a morphological errors between verbs and nouns. She made errors in function signs, so she would sign on instead of with, for example. And she made errors on multi-digit numbers. What does it mean? It means that the structure of the phonological output buffer in sign language is very similar to the structure of the phonological output buffer that we see in spoken languages. We have phonemes, which is the phonological parameters in sign language. We have morphemes, function signs, and number signs. Okay? So we see here again the interaction between the properties of a language and the way the dyslexia manifests in it, but we also see great similarity between languages. It is the same dyslexia in all the languages, it just manifests in a way that fits the properties of the language. And I'm going to finish in one minute, just by telling you 2 minutes, just by telling you something about the interaction between dyslexia and diglossia. So what is the condition of diglossia? And some of you live in a diglossic situation. This is work in collaboration with Manar Haddad Hana. We work in Israel where a lot of people speak Arabic, and Arabic is usually is a case of diglossia. So there is spoken Arabic. In Israel, it's Palestinian Arabic. Palestinian Arabic is the spoken Arabic, but in reading, they read standard Arabic, which is different in lexical aspects and syntactic aspects and phonological aspects. So what we see is actually people are reading in one language and speaking in another language. And there are dyslexias in which this is really crucial. And the one dyslexia like that is deep dyslexia. Deep dyslexia is a deficit in both the lexical root and the sublexical root. And then people have to read via semantics. So what they are doing is that they see the word, they understand it, and then they name it. So if they see, for example, the word jacket, they see the word, they understand jacket, and then they imagine a jacket, and they say jacket or jeans or coat. Okay? So people with this impairment make errors, semantic errors, and a lot of morphological errors. For example, if you see the word swam, S-W-A-M, you understand it, but you might say swimmer. If you imagine swam, you would say swimmer or swimming or swim, right? So there are a lot of semantic errors and morphological errors. In what way will this interact with a diglossic situation? So you read in one language, and then you have to name. If you name in your spoken language, it will be in a different language. So we worked with 7 patients like that, who had individuals who had deep dyslexia in Arabic. One of them was SU. And just to give you some examples of what she did, instead of saying blackboard, she read the word blackboard, but she said eraser. She read the word blind in one eye, and she said eye. She saw the word written port, and she said water. She saw the written word driver, and she said taxi. So she saw the written word, and she said, she understood it, and she said something that was related to what she was imagining. But importantly, when she saw a word that had a different word in the spoken, in the Palestinian Arabic, for example, the word tabib is a doctor, a medical doctor, she said doctor, which is the parallel in Palestinian Arabic. And when she wrote, when the written word was jalasa, sit in standard Arabic, she said a'ad, which is the counterpart in Palestinian Arabic. Okay? So she saw the word, she understood it, and then she was producing it in her spoken language. And not only did she use Palestinian Arabic, she also used sometimes Hebrew, because she lives in Israel, and some words like post or like a computer are used in Hebrew. So she saw the written word hasub, computer, and she said machshev in Hebrew. She saw the written word barid, post, and she said doal in Hebrew. So here we can see the interaction between, not only between the properties of the language, but also properties of the language context, the language situation. And here we see how diglossia affects the way deep dyslexia manifests itself. So I will finish by saying that the same dyslexia may manifest itself differently in different languages. But when we look at individuals who have bilinguals or multilinguals who have dyslexia, they have the dyslexia in all their languages. Sometimes it's harder to find this dyslexia in some languages, so we have to try harder. And we have to come up with the right stimuli and the right tasks that will allow us to identify the dyslexia in each language. And we saw that there are interactions between morphology, predictability, letter form, diglossia, and different kinds of dyslexia. So I thank my lab people, and I thank you.